In this video, we are going to talk about graphing of sine and cosine functions. So let's take a look at just the general way to write any sine cosine function. So this just has the a, b, h, and k in it like you're used to seeing in every function. And so let me show you if you had it written with a quadratic. So you'd have, y equals a times b quantity x minus h, and then squared and plus k. So you've had this kind of in every function that you've learned about. It could be a square root function, and you have the a outside of the root, and then you have the b and the x minus h inside of the root or inside of the function, and then that plus k on the outside. So we've had this multiple times before. You've seen what the a does, vertically stretching it. You've seen the h moving it left and right, the k moving it up and down. The b value you have seen, but it's kind of always looked like it does the same thing as the a value. So now with these trig functions, it's kind of going to be the first time that you're really going to see that the b value does a horizontal compression, okay, or a horizontal stretch. So this is going to stretch it left and right versus your a value stretching it up and down. Okay, so when we do take a look at this, so you'll see here that, so sine and cosine both look like this. They're just shifted of each other. So this picture shown here is actually the sine function. But the a value again is going to vertically stretch this. Okay, so it's gonna make these peaks and these valleys higher or lower. And then the h value, like I said, moves it left and right. So this h value here is going to shift your graph to the left or to the right. And then the k value, which is outside of your sine or cosine function, that's going to move it up or down. Okay, so this is going to be a vertical shift. It's actually going to move this midline. So it's going to take this middle line and move it up or down. So this is called the axis of oscillation because this function oscillates around it or moves around it, and it's going to keep going like that. And Delta Math will also call it a midline. And the equation of it is y equals k. So this k value will move it depending on what that k value is. And then, like I said, this b value right here changes how far apart these peaks are. Okay, so this is going to horizontally change the period. Okay, so the period is how far it takes to get through one full rotation. So you can look from this midline point or this starting point here up all the way down and back to the middle. That's one period. So you can look at it like that. You can also compare it peak to peak. So you could compare top to top. So this distance from here down all the way back up, that's also a period. It's the same exact distance, in this case 2 pi. So 2 pi is the normal period of the sine and the cosine function. So let's take a look at the difference between the sine and the cosine and at their parent functions. So a couple of things to note here is that the sine function starts at 0, 0. Okay, and this is because the sine of 0 is 0. So when we're talking about the unit circle, when we're here at 0 degrees, this ordered pair is 1, 0. The sine is the y value. So the sine of 0 is 0. So the sine function starts at 0. Okay, then at 90 degrees, or pi over 2, this is the ordered pair 0, 1. The sine value there, the y value, is 1. So at pi over 2, or 90 degrees, the sine function is 1. That's the maximum. Okay, then at 180, okay, over here at 180, negative 1, 0, sine is 0 again. Okay, you can see that at pi or 180 on the graph. And then at 270, or 3 pi over 2, you're going to be at 0, negative 1. So the sine is going to be negative 1. that's its lowest point. And then at 2 pi, it is back to 0. So that's the sine function there. So you'll see this amplitude taking over for the height. So the a value here is 1. So the max height is 1 and the minimum height is -1. There's no b value. Well, there is a b value. It's 1. Okay, so the b value is 1. So the period, remember, is 2 pi divided by b. So 2 pi divided by 1, which is just 2 pi, meaning it's going to get through that whole thing in 2 pi. Okay, the h value is 0. So this is really inside here says +0. And outside of here also says +0. So there's no phase shift, this h value, and there's the midline is 0. It hasn't moved up or down from the axis. So cosine is very much similar. Okay, again, there's no phase shift. Okay, there's a +0 in here. The b value in there is 1. So the period is going to be 2 pi divided by 1, which is just 2 pi. And then there's no k value, or the k value is 0. So it stays on the x-axis. The axis of oscillation is just y equals 0. And the phase shift hasn't shifted. And then the amplitude is 1. So a max of 1 and a min of 1. Now for cosine, okay, cosine is the x value. So cosine of 0 is 1. So cosine starts at its maximum. Then at 90 or pi over 2, cosine is 0. Okay, so cosine starts at 1, then at pi over 2, it's 0. At pi, it's -1. At 3 pi over 2, it's 0. And then at 2 pi, it's back to 1. So cosine always starts at its maximum value. Then it goes to the midline, down to the min, back up to the middle, and all the way to the maximum. So sine starts at a middle, okay, starts on its axis of oscillation, and cosine starts at its maximum. Those are the big differences. All right, let's take a look at graphing one of these. So we're going to graph f of x equals 3 sine of x. So first off, we see this a value of 3. So this is the a value. So that means that that's our amplitude. Okay, so our a value is 3. So our amplitude is 3. Now the a value could be negative. That's going to flip it over. If you saw it said the amplitude is equal to the absolute value of a. So the amplitude is always positive, but this could be a negative, in which case the graph is going to flip over the axis of oscillation. The b value here is 1, which means the period is 2 pi divided by 1, or just 2 pi, just the normal period. H is 0. There's nothing added or subtracted inside of this function, so the phase shift is 0. And then the k value out here is 0. There's nothing added, which means that the vertical shift is 0. So when I'm graphing on paper, I like to put in these things. So I like to do a dotted line where the phase shift is. So in this case, there wasn't one. So just on the y-axis, the vertical shift, or the midline. Okay, so the midline, there was no shift. So that's just going to be on the y-axis. And then I like to do the amplitude. Okay, so the amplitude here was 3. So that's going to be 3 up from the midline. Okay, and in my case, these are half units. So 1, 2, 3 up from the midline, and then 3 down from the midline. So 1, 2, 3. So that's going to be the high and the low values of our graph. Okay. Then the next thing I do, well, actually probably the first thing I would do normally would be work with the b value so that we knew if there was a phase shift, but there wasn't any phase shifts here. So I would probably deal with the period first. I will in the next one. But so the period you want to look. Okay, so this is 2 pi. So figure out how far 2 pi is on this graph. So we see pi plotted here. So that's 1, 2, 3, 4, 5, 6, 7, 8 boxes to get to pi. So another 8 boxes, 1, 2, 3, 4, 5, 6, 7, 8 would get us to 2 pi. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 would get us to -2 pi. So now you need to split these, because if you remember what I looked at with the unit circle was every fourth of a way around the circle. So this would be once around. Okay, so every 1/4 of the way, okay, we were on the we were on a quadrant, getting us a 0, a 1, or a -1 for these dots that we plotted. So I'm going to split these into a fourth. Okay, so 2 pi split in half was pi, split in half again. Okay, so half of 8 boxes is 4 boxes. So 1, 2, 3, 4 boxes. That's going to be half of pi, or a fourth of the unit circle. So then we've got 1 here, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so there's always going to be a max or a middle or a min at these. So 1, 2, 3, 4 this way, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So these are the only ones that I really worry about, because that's going to be these points on your unit circle. Okay, they're going to be coterminal angles with that, and it's just going to keep rotating around this. Okay, and for sine, that's going to be a middle oscillation axis, maximum, middle, minimum. Middle, maximum, middle, minimum, because sine was 0 here, 1 here, 0, -1, and it just keeps going. So then when I go to plot this, okay, so at 0, sine is 0. At pi over 2, sine is 3 in this case, because it's at its maximum. At pi, sine is 0. At 3 pi over 2, sine is -3, because it's middle, maximum 3, middle 0, minimum -3, back to middle. Because now these are shifted, right? From that A value, the maximum is now 3 and the minimum is now -3. So then going backwards, okay, it follows this pattern. So when we graph this, we're going down when we go back down. So this will be at a minimum. This will be at a 0. This will be at a maximum. This will be at a 0. And then you can just connect it, connect it with a curved line. Okay, because it's not straight lines to connect those. They're not absolute values, they're not pointy. So do the best that you can on your paper, and then you'll get that sine function. So this one is just the exact same as the initial sine function, just at a height and a top and bottom of 3 and -3. Next one, so 2 cosines, so this one's going to be very similar. So our amplitude, again, is the number in front of the cosine, so that's 2. And so the amplitude is 2. We have a b value of 1, so the period is just 2 pi. We have an h value of 0, nothing added in there, and we have, so a phase shift of 0. We have a k value of 0 and a vertical shift of 0. So first thing that I should have done last time is deal with the period. This one's still a normal 2 pi period, so nothing is going to be that drastically different from last time. So again, remember what I do is take the entire 2 pi period, okay, which is 16 units here, because this is the same graph as last time. So this is 2 pi. That's 16 total boxes. And then I split it using the unit circle. Okay, and the unit circle is in fourths. So I divide this by 4. So here's the period is 16 boxes. 1/4 of that is 4 boxes. This is where every min, middle, and max is going to happen, is every 4 boxes. So then I draw those lines on, because that's going to give me my pi over 2, my pi, my 3 pi over 2, 2 pi. That's 1/4 of the way around the unit circle each time. So in case there was a shift or anything you needed to do, you'd have your graph axis labeled. In this case, we have no phase shift, no vertical shift or axis of oscillation or midline shift. We do have an amplitude change, okay? So that's going to be up 1, 2 from the midline, or down 2 from the midline. Even if the midline has changed. So if the midline has moved, then you would count 2 units from the midline, okay? So my midline is just still the x-axis here. Or sorry, yeah, the x-axis. Okay, so then start plotting the points. Okay, so now cosine, remember, when you're looking at the unit circle, okay, cosine is 0 at, or sorry, cosine is 1 here. Okay, this is 1, 0. So cosine is 1 at 0. At 90 or pi over 2, cosine is 0. At 180 or pi, cosine is -1. And at 270 or 3 pi over 2, cosine is 0. So remember, now this will change because of the amplitude. So now this is going to be times 2. So this will be at 2 and this will be at -2. But then this is what it's going to do every single time around. So at 0, cosine was at its maximum. At pi over 2, cosine was at 0, or the midline. At pi, it's at its minimum. At 3 pi over 2, it's at its middle, or 0. And at 2 pi, it's back to its maximum. Okay, so I was just following around here. 2, 0, -2, 0. Okay, then going backwards. So remember, going backwards would go this way, right? So here, we'd be coming back down to the middle. 1/4 more, we'd be at a minimum. 1/4 more, we'd be back at the midline. 1/4 more, we would be back at a maximum. And then you can just connect those. Again, best you can, and don't do pointed, so don't make them like super pointy. All right, then let's take a look at a shift here. So this one is now in degrees, okay, and it has a shift in there, okay. A value is 1. Oops. A value is 1. Amplitude is 1. B value is 1. So period is 2 pi. H value is 90, not -90, because remember it's x minus h. So the h value is 90, which means that there is a phase shift 90 degrees, and this will go to the right. And then k value, number outside here, nothing, so 0, so vertical shift is 0. So let's again deal with the period here and make sure that we split the graph before we start doing our dotted lines. So this now is 1, 2, 3, 4, 5, 6, 7, 8 boxes to get to 180. So we're still going to be at 16 to get to 360, or the full period. Oops, so I shouldn't have the period in radians. I should have the period in degrees this time, since we're using degrees. That's my fault. And then split this into fourths. So every 4 boxes now is going to be 90 degrees. Or 1/4 of the way around the unit circle, or 1/4 of the way through this graph's period. Okay, now we're going to need to shift. Okay, so now we're going to do some things here. Okay, so the B value, nothing, or the K value, nothing. So we can still leave the axis of oscillation, or the midline, at y equals 0. So this is still here at y equals 0. Now, the phase shift will have a phase shift happen. Okay, so normally it starts here. Now we're going to shift this to 90 degrees. Okay, so 180, half 180, 90. So we're going to shift over here. So now we're going to be starting on this red line. Amplitude, 1. So 1 above and 1 below the midline. So now you're starting here, okay, on this the red and the blue line. Okay, that's where you're starting to do all of your cosine things. Okay, so again, around the unit circle to plot all of these points, it's now starting here. This is now considered 0. Okay, so remember, the x value here is 0, the x value here is 1, x value here is 0, x value here is -1. Okay, so that's still going to happen because our amplitude is 1. So these are still going to be, the high and the low is still going to be 1 and -1. And the vertical shift hasn't done anything to the midline. So these are still going to be at 0. Okay, we're just going to be starting here now. Okay, we're going to be starting on this red line. So cosine starts at a, oh, did I write these wrong? Yes, I did. I wrote these wrong. I did them as the y values. Okay, sorry. The x value here is 1, 0. So the x value here is 1. Okay, the x value here is 0. The x value here is -1. I'm sorry. The x value here is 0. Okay, so the x, the mins are still going to be 1 and -1. And then the middles are still starting at 0, okay, because of the phase shift again. Okay, so start plotting them on this red line. Okay, so cosine starts at a maximum. Okay, so now we're starting here. Okay, on this phase shift at a maximum. Then a fourth of the way through will be at a midline. Then another fourth of the way through at a minimum, right? So max, middle, min, middle. Okay, and then back to, then you would get to the max on the other side, which we're done plotting. Okay, so I'm going backwards. A fourth of the way you'd be at the middle. Another fourth of the way you'd be at a minimum. Another fourth of the way you'd be at a middle. Another fourth would be a max. Another fourth would be a middle. So it always does that. Max, middle, min, middle, max, middle, min, middle. It just keeps repeating. And then you just connect those. Okay, so depending on how your graph is, if you've plotted it out, then you can get the middle, max, middle, mins in there every fourth of a way. Okay, so then that's the cosine shifted over 90 degrees. So I could actually even on here probably pick this up and just show you this would have been a normal cosine without a phase shift. This is a cosine shifted 90 degrees to the right. Okay, then let's look at this sine function with a b value change here. Okay, so the a is 1, so our amplitude is 1. Now we've got a b value of 2. Okay, so with this b value of 2, the period is 2 pi divided by b, so 2 pi divided by 2, or just pi. Then the h value is 0, so our phase shift is none. The k value is 0, so our vertical shift is none. So let's take a look. Now we don't have any phase shift or vertical shifts, so we could put these blue and red lines in because they're not going to matter based on the period at all. Okay, they're going to be at 0 and 0. So now when we go to deal with the period, so again, the period now, so this b value is going to shrink this graph, okay? So now instead of it taking 2 pi to get from here to here, okay, now instead of the length of that being 2 pi, the length of this is shortened to 1 pi. Okay, so instead of getting through this in 2 pi, it's going to get through this whole thing in pi units. So you're going to see a lot more of these maxes because we're going to get double the amount in, which is what b means, is how many times can you get a cycle in 2 pi units? Twice. So each period is pi. So now when we go to look at this, we're going to look to pi. This is 1 period. That's 8 boxes to get us 1 period. And remember, a min, a middle, and a max happens every fourth of a period. So 1/4 of a period on here is 8 divided by 4, or 2 boxes. So then I'm going to split this every 2 boxes. Something's going to happen. So we've got 2, 4, 6, 8. So every 2, okay, every 2, something's going to happen. Okay, a min, a middle, or a max. And then backwards, every 2 units, something's going to happen. I'm going to change the color to graph this. Maybe I'll do a brighter pink, so hopefully you can see it a little bit better. And then the amplitude here is just 1. So 1 and -1. All right. So sine starts, so it's the y value, and the y value here is 0. The y value here is 1. The y value here is 0, and the y value here is -1. So again, these represent the middles. So if the middles changed, that would change. And then these represent the max. So if the amplitude had changed, those would change. So sine starts at a middle. Okay, and we're starting on the red line because we haven't had a shift. Over 2 units, sine's at a max. Over another fourth, it's at a middle. Then a min after another fourth of the way, and then a middle. So take a look at this. So it gets through one cycle. Okay, it goes to 1 max, 1 min, and back in pi units. Okay, so it should get through 1 period in pi units. That's what we decided, and it did. Okay, and so now we've been middle. Now we're going to go max, middle, min, middle. Okay, then backwards. So if we're looking at it backwards, we're on the down swing here. So this will be min, middle, max, middle, min, middle, max, middle. But then you can see, so again, this B value is how many periods you get through in a normal cycle. Okay, and the normal cycle would have been 2 pi, which is this whole half of the graph. So how many cycles did we get through? 1, 2. So in 2 pi units, you got through two cycles of the sine function, which is what you wanted to happen. All right, then determine the period. So these ones are just calculations instead of actually graphing. So just figuring out the period here. So remember, period is 2 pi divided by b. So you need to find your b value, okay? So your variable is x. So your b value is 4 pi over 5. So you're doing 2 pi, and I would just write it like this, divided by 4 pi over 5, because then you're going to flip it. Okay, so flip the second and multiply. So then those pi's are going to cancel, and you're going to get 10 over 4, which then simplifies to 5 over 2. So the period of this one is 5 over 2. Next one, so again, your b value here is 2 pi. So you're going to get 2 pi, and this one's not, like this one was a fraction, that's why I wrote it this way. If it's not a fraction, I'll just write it underneath. So 2 pi divided by 2 pi, just 1. B value here is 4, so 2 pi divided by 4. So simplify 2/4, which is just 1/2, or pi over 2. A fraction, so again, this one I would write this way, 2 pi divided by 4/7, so that then you can flip it and multiply. So change it to multiplying and then flip that fraction. So you're going to get 14 pi on top over 4 on bottom. Divide by 2, so you get 7 pi over 2. All right, then writing the equation from these. So the given one is just cosine of x, and then you need to shift it using the a, b, h, and k values here. Okay, so what I would look at this as is you've got a midline here somewhere. Okay, that's shifted, that's your k value. Okay, so normally your midline is here on the x-axis. Okay, and now that's moved down to the middle of the graph. So remember, the max up and down from here have to be the same amount for this to be in the middle. Okay, one other way you can figure that out is looking at the amplitude. Okay, looking at the top and the bottom numbers, and then the midline needs to be in the middle of that. So this new graph down here has a top number, or a max of -3 and a min of -5. So the midline right in between there is going to be -4. That's your k value. Okay, then cosine starts at a maximum. Okay, so look at this line here and see if it's starting at a maximum, which it is. So there has been no phase shift, which they've shown you because they haven't put in an h value here. Okay, a value, how far is it from midline to max and midline to middle? So how far away are those? 1. and then the period. So the b value deals with the period. So take a look at one cycle, or to 2 pi. So I'm just going to look here at this one. Okay, so that got through 1. It went max to max. That's 1 period in that 2 pi time frame, which is the same down here. Okay, max all the way over to the next max. That's 0 to 2 pi. So the b value is just 1. Next one. So again, if we take a look at the amplitudes here, okay, so here's the amplitude of the initial graph, okay, that solid line graph. But the amplitude has changed now for this dotted line, okay? So the amplitude for this dotted line, the top of it, the top of the dotted one is at 1, the bottom is at -5. Okay, so we need to find the middle of that. Okay, so the middle of 1 and -5. So you can do 1 plus -5 and just find the average, divide by 2. So that's going to be -4 divided by 2, which is -2. So the b value, or sorry, the k value is going to be graphed down here at -2. So y equals -2 is the midline. That's your k value. Then your amplitude is how far is it from the midline to the max and the midline to the min. These should be the same number. So -2 to 1 is 3. -2 to -5 is 3. So your amplitude, 3. Then you want to look at the period. Okay, so look at one cycle of this. And I think it's easier to go from min to min or max to max. Okay, so I'm just going to take this max here and go around and see how far that was. Okay, so this was pi over 2 all the way to 5 pi over 2. So just subtract those to find the length between them. So 5 pi over 2 minus pi over 2 is 4 pi over 2, which is 2 pi. So that's the normal period. So your b value is 1. Next one. Okay, we've got the normal solid one here from 0 to 2 pi. Okay, so let's get these amplitudes in here to check the amplitude in the midline to see if any of that has changed. So on the dotted line, here's the maximum. Here's the minimum on that dotted line. Okay, or on the dotted graph. So the max is at 0, the min is at -2. So halfway between 0 and -2 is -1. So your midline is at -1, which is your k value. Okay, and then the amplitude, the distance from the blue line to the max and the blue line to the min, that's 1 and 1. So your amplitude is 1. Then we have to deal with the period. And you can see that the period is different here. Okay, because we see one cycle through in 2 pi on this solid line. And look at how many times we see it here. Okay, a bunch of times here. So what we have to do is figure out how far is it for one period. Okay, and then figure out the b value. Now, I said it's easy to go from max to max, but in this case, the max doesn't tell you what the angle measure is right here. You could figure it out by doing half of pi over 4, but in this case, I would probably just start at a middle. So I'm just going to start here at pi over 4 and then cycle through the whole thing. So this is minimum, back up to maximum, back to middle. Okay, that's one full rotation at 3 pi over 4. So then I'll subtract those. So 3 pi over 4 minus pi over 4 gives me that there's a 2 pi over 4 distance between there, or a pi over 2 period. Okay, so this is the period. So now we need to find the b value. Okay, so remember that your period equals 2 pi divided by b. So if you just switch these two on the diagonal, b is equal to 2 pi over your period, which is what we want. We want to solve for the b. So we'll do 2 pi divided by pi over 2. Again, it's a fraction, so I'm going to write it this way. so that I can flip it and multiply. So then the pi's will cancel. So I'll get b equals 4. Now, one other way you can look at that to check it is here's 2 pi. So you could look at how many cycles you get through between 0 and 2 pi. So this is 1 cycle, 2 cycles, 3 cycles, 4 cycles, and that's going to be your b value. All right, last one, determine the equation of the midline of the following graph and the amplitude. So just come up with the equation of the midline and what is the amplitude. So I like to draw on the amplitude first, so because it's the top and the bottom, and then right in the middle of that is where you need your midline. Okay, so then draw, the amplitude here, the top is at 2, the bottom is at 0. So right in between there is going to be your midline. So in this case, y equals 1. But so if these were harder numbers, you just add these together. So you just add the max plus the min divided by 2, and that'll give you your k value. So you just do max plus min divided by 2, and that'll give you your k value right in the middle. So our equation of the midline is y equals 1, and then our amplitude is 1 because it's 1 up and 1 down from that.